Good day, folks. Just bear with me. I'm trying to test my setup here with the laptop as because my webcam is actually acting a little weird, so I decided to use the laptop. But I don't get it because I actually have the tripod and everything for the camera, and it was all set right. But now using the laptop, so I'm trying to get. I think that's okay. So these are just basically my random chats. I just go on here and say hello. And there's not much on the agenda today, but I hope everyone is doing well and the weather is nice. So I tend to ramble on a little bit in the beginning just to let people know I'm actually here. So before I actually get carried away, I got like a bunch of meters, like 7 of them, and batteries are all dead. It's cold winter, so I get lazy. I don't want to go out there, take my car, and drive someplace and get new batteries. It's too cold. So I actually ran out. Now I need to find a screwdriver because, why do they always have a screw in these meters? That's so annoying. It should be just heavy duty snap. Because a guy like me, who uses this all the time, like 2 weeks and the battery needs to be changed. Having to screw it all back in there. And these cases are, this is turning into a bad review of Fluke voltmeters. And then this super heavy duty case that makes you want to rip half your skull every time you rip it out just to change the battery. So I found a 9-volt battery, believe it or not. So maybe that's going to save the day. Not sure if it's got power or not, but if I can find the right screwdriver in all my junk here. So this is basically all unscripted, by the way. So don't mind if I disappear for a moment or I pause or whatever. I'm just right now, and don't let any funny noises scare you. All right, I think I found the right screwdriver. I got like 4 cupboards full of screwdrivers. One of these days I'm gonna make one of, well, it's hard here because it's an apartment, but in the workshop, you can set up you can bolt the actual organizer and just put them all in there. Maybe I can snap something. Oh well. So anyhow, I hope everyone's doing well, and I'm just trying to find a battery here. I can actually get 1 meter going. This one is dead. Maybe this one has power. I don't know. And that beep is not a good sign. No power. Wow. Okay, so now we have 2 dead 9-volt batteries. I could maybe borrow another identical meter. This is like the dark side of the experimenter here. Dead as well. Oh my goodness. And the thing is, if we get door delivery, I just order like 100 9-volt batteries on Amazon and just forget about it, right? Have it at the door. But I have to go like 2 miles uptown in a cold, frozen, 30 below car to get something at the post office. So I got this here. Transistor tester, maybe the 9-volt battery on this one here. This is crazy. Borrowing 9-volt batteries from. But I really do go to, and the place I go, the ironic part is where they had the batteries in the cash out section. They're not there no more. So every time I go like to get groceries or something, it doesn't register in my mind because I don't see them anymore. To remind me that, I need these batteries. Oh my goodness, a little over halfway. So this will do. Turn it off to preserve it. But hey, we're on a good start. Put that screw back in there, that crazy screw. I don't know why they do that. It could just be a heavy duty snap. Put this case back in there, which is like impossible to remove. Okay. We're getting somewhere. But I really do gotta go uptown somewhere and get some batteries. Maybe tomorrow if it's nice. They're saying more and more snow squalls in the forecast, believe it or not. So I'm just not a fan of having to scrape the car, blow the snow off, shoo it away, and the wind is taking it back in your face again at 30 below. It literally makes you question your whole life existence right there on the spot. So I try to avoid that as much as I can, that whole experience. And yeah, oh my goodness. Yeah, if anyone's wondering why I have a shaver on my workbench, this is the craziest thing. My old one died. I buy a new one online, I think. Oh my goodness, for almost $300 is going to be pretty good, right? But the idiots make it USB, so essentially they pitch it as a marketing thing. But guess what? They don't have to include a power supply no more. It's universal. Yeah, well, that means I got to find one of mine, and then I have it on my power bar because it charges my USB stuff. They give you this USB cable and then, essentially shove it up. You know what? It's so insulting. You pay that much for the machine and, you don't get it, as if a little thing, power supply that would plug in the wall. It costs, 50 cents to make. That was too much for them. Oh. So now I look silly charging this thing on my workbench, but it's the easiest access I have to all free USB devices, So I found that really silly. Canadian Tire, by the way, if anyone's wondering. Canadian Tire online. Boy, oh boy. I read Universal. I figured, okay, so they're going to have at least, usually they have the USB thing that comes with it, even a cheap one, right? No, just the cable. Here you go. Works in any country. Yeah, no shit, Sherlock. They're trying to pitch it as a feature, right? But really, it's to save money, but they don't want to say they're flat out screwing you over. So they're like, it's universal. It works anywhere in the world where there's a USB port. Yeah, okay. So in other words, I got to provide the power supply. So yeah, what I was going to do is I have all these power cells here. Solid state, different compositions. And I just wanted to measure to see if it was still working. So I'm going to do that now, actually. Turn my meter on. Put that on there. So there's still something. 1.39, 1.4, 1.3. You can see that. So, but I don't have another battery source. I wanted to try something here. Well, these ones are half dead, so I could try something. Let's see what's left in this one here. 9-volt battery. That's really dead. 2.5. Wow. Okay. So I'm going to try something really, really quick here. I've never tested how they behave in this configuration. So basically I'm going to connect it as it says plus minus. So plus here into the minus here. Just a series DC circuit. So what's going to happen is this cell will have the tendency from what I've experimented with before to reverse bias itself because it's just too weak. So I just want to see the difference between just like this. So 2.5 here and 1.5 there roughly. What it's going to do versus if I would put a diode to isolate the output and then go series. See if it'll boost it or not in this configuration. So that's basically all I had in mind here real quick. So curiosity more than anything. So 2.7 there. 2.7. So it's hardly, so that's what it's doing. It's basically, it's not able to provide a constant, like a regular series. So essentially why they say all your cells have to be matched, right? If you're doing a series, because it's going to use the maximum current is what your worst cell can provide essentially in the whole loop. But that could be exploited, as I explained in much earlier videos that I showed that could actually be your pure potential gate if done right. So 2.7, so 2.56, so it really is basically absorbing and flipping, because it wouldn't be, in other words, if it would be working, like if it had more voltage, I'd be able to get the stacking effect, right? So I want to see, where's my diodes now? If I isolate it, if it's going to accumulate or if it's still going to drop. So I'm going to find a diode here. Look at the specifications real quick. Looking for fast recovery switch rectifier. I would say rectifier will work. 30 pieces here. And then 1N4001. 1N4001 sounds good. I'm just going to put one of these diodes here. On the positive side of the cell, and then do the series thing. So the whole idea is the diode isolates the cell from seeing the battery, right? But allows only the one-way path. So I'll see if that shows me a diminished performance or an increase in potential. Just something I wanted to see how this specific cell behaves in that kind of behavior. If it's following the same pattern as the others or not. I'm pretty sure it's just going to follow the same pattern, but you never know. So plus over here, negative over there. That works, 2.93. So see that? I don't know if I can show you this from there and hold it. I'll put this closer here so I can do it with one hand. Plus over here, negative over there. You're going to see that. So it was like 2.7 and dropped. Now with the diode, and of course there's a forward drop of the diode, you got to remember, right? But I'm just trying to isolate both cells to see if the power cell is isolated, if it produces more of a pure potential or not. So I had a gut feeling it might. So here with one hand, if you're going to see that, try and put it closer here. And then we're gonna, well, I'm at the end of my wow, it's hard to do with one hand live. Maybe I'll put a clip. There we go. 2.9. Did you see that? I'll hold it. It's hard to hold there. My goodness. 2.8. So it peaks at 3. So yeah, I mean, it's hard to, I don't know if you understand, but there's a gain of about 150 MA. And you got to remember that's overriding the diode's forward gain, which could be anywhere 0.2 to 0.4 of a volt. So let's say 0.3 plus. So there's like a 450 450 millivolts essentially of a boost, but unfortunately our diode eats, because this is so little, right? But if I had like, 15 of these, then the forward drop of the diode wouldn't hurt it so much, right? But only having one, um, essentially the diode eats 75% of the gains, but there's definitely a gain there. So back to what Tom Bearden was saying with the nonlinear element, if you want to look at it in that way as well. So that's essentially what I had in mind, just to see what it would do. So yeah, there's definitely a gain there because I get a little bit more with the diode in consideration of the forward loss, right? So it's busting through that. And this battery basically is dead. It's only 2.5 volts, but I just wanted to use it for the stacking just to see what would happen. Oh yeah, the big experiment of the day. Power cells work better when you isolate them individually with a diode before seriesing, stacking them in a series. So yeah, what else to talk about? I was I'm gonna have to do a video of the Scalar stuff again. I've been doing that on the side, talking about some Walter Russell stuff, and a lot of people are into it. So I should add more. I added more context to the website with calculators because people were asking questions about it, like what do you do with this? What do you do with that? So I added a bunch of static charts for the elements. Because obviously, if you use the chart and you get an element to let's say to make a core with, and it's something that would literally blow up, you can't use that, right? But you take the atomic signature, in his charts and find something close that you could actually use, right? So that's where I put like the equivalence charts, all just a neater way of basically spreading the information we already know. Just it's just neater to have it all in the groupings like that. But we're not doing anything magic. We're not giving these properties any new meanings or anything. It's all the actual resonance. It's the actual formulas. It's calculating LC circuits. It's just like I said. It's just a better, or for what we're doing, it's just better organized, I find. So that was my previous video on a Scalar lab, which was a few web scripts for calculating phase canceling coils and that sort of thing. Also calculating phase conjugate pairs, the right elements, as Tom Smith. Tom Smith, that would be a good one. As Don Smith would say, with the different elements, right? Where the primary coil is copper and the secondary coil should be something else, so that it does a lens correction instead of fighting against you. So all of that is in there. And it's just grouped in neater context. So a person doesn't have to guess as much. They have a certain element, what's the best thing, and what the frequencies, right? Because every element has its natural frequency you want to go within that range. And it gives you the nice calculators. You basically enter everything about you, because everyone's going to have different stuff, but you could measure your impedance of your coils, put that in the calculator. It'll tell you at what frequency with what element. Let's say what you pulse this and make sure your switch fully turns off in 20 ns at whatever the frequency of your element is. So you experiment with duty cycles. I would say anything over 25%, you're wasting power. Simple Radian Bedini style charging, anything about 5% is great. Anything lower is even better. If you want to transfer energy efficiently, resonance-wise, again, 10-15% for the biggest coils, because you got to partially be able to energize the whole thing, right? So for heavy loads, you're going to need to put in a little bit more into the input, but essentially to be able to get into that NS range for the shut-off time anyways, it defeats the purpose of having a very long duty cycle complemented by it afterwards. So you're going to come to conclude that it's going to be essentially all high frequency and sharp transient shut-off times to maximize the whole effect. But it's all on there. It's all on there. Different. That's why sometimes I have a hard time explaining this stuff, because depending on who's building what and what they have to use, it's completely all similar, all interconnected. But the resonance point might be different. The switching, I'm switching at 2%. I found personally with just air coils at 1.9 ohms that they were best switched at anywhere from 2 to 3%. So 5% would probably be a great maximum, would be a great, but make sure whatever it is, it tells you, let's say 20 NS. So, 5%, but make sure that your switch turns off within that period of 20 NS. So MOSFETs do it. NPN transistors do it, very sharp switching if you reverse bias them. There's a trick about that, actually. So reverse bias your NPN transistors and they become very sharp transient switches. I'm sure some solid state devices are as well. But if you're going to push any significant potentials, it's probably not going to be an IC directly that's going to do it. So you're probably going to have a few buffer stages and either a transistor or a MOSFET, right? I think, anyways. Crude experimentation relays work because you got the noise between, because it's a mechanical thing. But just like the spark gap, that's essentially brute forcing the effect. You can have a much cleaner version of it and actually zone in on what it is you're trying to pick up. Because essentially what's going to happen is, let's say the calculator tells you, okay, 20 NS, and your elemental frequency, let's say, is 380 hertz. Well, essentially what's going to happen is in that 20 NS range, it's going to carry, like, I'm just making it up, but let's say 1.4 gigahertz, super high frequency. That essentially becomes a high frequency component embedded within the slow frequency, which then hits a nonlinear element, which causes it to do a phase conjugate correction. If you have, again, find that element that matches barium titanate or whatever, then not only do you get the lens correction, but you get the phase conjugate effect. So you stack the two together, and this is where people would essentially what looks like gain in relative to the input. But how you do it, oh my goodness, there's not really one. That's the problem with these solid state switches. It's all over the place. Bedini had his style. Don Smith has his style. Floyd had his style. Everyone has their style, depending on what they have to work with and what they know within the domain, but essentially, and that's why, it's all familiar, but there's what you know of how copper is going to react at a certain frequency might not be how nickel is going to react, let's just say, So it's not always as simple as I've got a coil, I've used the frequency, I built a Bedini solid state, but I'm going to build replicas, and then you use, let's say, a different kind of wire. And it's different. You don't know why. You've used the same line, just different. Shouldn't matter, right? But when you group it, let's say, in the Russell groupings with the known material properties and those elements, you see, oh my goodness, I got literally the opposite pair that I need here. Switch it around and just, okay. Like I said, we're just taking the numbers and grouping it up. And I think I will get into that. Maybe I'm going to make a few publications explaining more how these grouping work. And, how this universal scale works and how it may be applicable how it directly is applicable to energies in the 0 point. Because The zeroth point is basically an extension of what Walter Russell defines as, the universal one, the light. So we could definitely, meaning, yeah, there's a lot in there. And I think, yeah, but I don't want to get too off topic, right? Because Walter Russell and similar philosophies basically almost have a place of their own, right? So, but I like being able to take out the pieces and merge what's important, what's relevant, and try and decode it in relevance to what we're doing here. And it's like one can accomplish, as you see on the site that I shared, it's like Tom Bearden's insight a complement what Walter Russell had to say, and you put the two together, and you get a much more scientific picture versus, but as you see, it's very interesting, and I will, I think, get a little bit into that in the upcoming days. And on a side note, my power cell today, I check in on my little clock over here. It's been running since December on a different kind of power cell I'm experimenting with. Still nice and good. The one I isolated in oil is actually the one that's working the best. Completely isolated from the external environment. That's moisture, that's air, that's any inherent gases out in the it's a pure potential difference. So very electric, which people in the beginning were arguing with me, saying, oh, no, that's not it at all. We've built a Zamboni pile and it's using the environmental moisture and it's going to corrode. That's what some people were accusing me of. So I said, yeah, okay, in the oil. Happens to, and what's the ironic part of it is it happens to be the one that performs the best. So now it's like, it's all, I don't know how to explain it, but it's almost like the external environment in its full openness with these kinds of cells actually deteriorates the performance versus having it completely sealed in its own environment. So that's telling me something about the properties of these cells, which is very interesting because it goes against what everybody was saying, that you were just siphoning essentially off a subtle but very slow galvanic / moisture effect. Nothing to see here. Let's move on. So I've been arguing that from the start, that there's more than meets the eyes, and with all the various explanations that I've been given over the last few years. But this really does really put a light on it. Anyways, it's a nice way of isolating it, that's for sure. So I check on it every day, even for a hiccup or a diminishing, and then in the clock, right, the LED, I might get light or not as sharp, but very sharp. Just keeps going. So that's very interesting, but very dirty to have, a cup open in oil. But again, future generations might just be a fully vacuum sealed and completely isolated from the external environment. This way here, it wouldn't make a mess if it gets shaken up, right? But the prototype is always going to be messy, right? But what I'm finding fascinating is this generates current and is continuous. It's more of an electrostatic effect at this point. And at the rate, there would have been a reduction in mass by now, and there isn't. So that's, for whatever it's worth, noting. So yeah, I hope everyone is having a good evening. Well, good evening for me where I am. I'm sure some people it's morning or whatever. That's the internet for you. And my goodness, I'm looking around and I'm trying to figure out how I want to proceed for the next phase here. There's like 10, I shouldn't say 10 things, more like 100 things I want to do and try. And it's just trying to organize everything into something more coherent that I could actually start with. Because I tend to go like on eBay and then see what happens to be available. And oh, if there's a good deal on something like from some scrapyard on a project I know I'll have in the future, I'll just buy that one part, but not the full piece because I'm not there yet, but I know I'll need this thing. And it's literally, instead of 4,000, it's like, $40. So I'll go and so what happens is I get a lot of stuff, but not exactly everything I need for one specific particular project, because I find that if I want to, like just these, for example, these plates to do the supercells, two of these over $100, right? So I want to build a few of those in one shot, like $500 in one shot for a project. It's a lot of money. But if I know, like mentally, what are a range of things I want to experiment with, if I happen to browse on eBay and someone's selling scrap copper for $20 a plate, I grab 10 of them right away, right? And just put them on the back burner and then get back to it whenever. So that's what's been happening. A lot of stuff, but very miscellaneous, and one doesn't necessarily connect with the other. Just I know that holy moly, I can't normally afford this, but this one here's got a great deal, so I'm going to take 10. If that makes any sense. I've been doing a lot of that. But now I got to start structuring, look at what I got, and then decide, okay, am I going to get back into like version 2 of Bedini stuff? Am I going to continue and make the power cells better? There's different angles to go here. And am I actually going to get out of here? I'm having weird ideas because, I'd like to maybe, I don't know, rent a lab somewhere, maybe space. It's getting, not even for the company, just for myself, it's getting to that point that I could probably do that. But I have to make sure it's beneficial for me and it's actually worth it. I'm trying to think, could I have some internet business on the side, selling, not this energy stuff, but something else I had in mind, wireless stuff. But because I'm in the Scalar communications, I'm trying to develop a global wireless system that doesn't use traditional radios. I'm actually doing pretty good on that. And trying to figure out how I could protect at the same time sell a system that could work, and develop it actually first. I've got the whole blueprints for it and the primitive experiments, but now I gotta. So essentially, what I want to do it's Wi-Fi, non-line of sight Wi-Fi using Tesla's scalar, like longitudinal, instead of the transverse effect. So I got all of the using Wi-Fi essentially. But this is completely different. The Wi-Fi is just part of basically the controller that feeds into the whole assembly. And there's a special material and then a bias and a tuning program at both ends and a bunch of sensors to find the lock. And when that establishes, essentially in the RF world, you get I don't know how to explain it, but it's like when the resonance finds a lock, like in a DC bias, all of a sudden your forward, like what would be your SWR goes right down because the energy has somewhere to go because it made that lock. So that's essentially with the help of programming that we have now and Arduinos and things like that, that becomes, and borrowing a bunch of radar stuff with a microwave band to do it. So you already have the splitters, the mixers, and everything. So I'm thinking, holy moly, split it, inverted, nonlinear element. I'm really simplifying it here, but and then essentially you have a high-speed communication system that goes faster than the speed of light, essentially subspace, Wi-Fi. And I'm scratching my head and I'm wondering, why the hell isn't the military not using this? Perhaps they are. I'll find out shortly when I start roaming around in that frequency range. That's what you want to call it. But I was actually thinking of making myself a side business with this, if it works as good as I think it works, and selling like all kinds of different bandwidth requirements, the LoRa equivalent, the IoT equivalent, and all of that stuff. I'm thinking here, oh my goodness, farm fields that have sensors, no line of sight, foliage, and all that stuff. It can't interfere with radio. They're near. I don't know. There's so much potential for a radio-like system that's not actually radio, that is high-speed capable. It's just the tuning is a little bit. It sounds a little bit occultish because like like for example, radionics, about a host and all that, but you have to use the physics equivalent of that. That's what Tom Bearden describes by giving your nonlinear element a static DC bias. Then you have a receiver and a transmitter which lock into the same. They become electrically and physically and geometrically the same. So as far as the universe is concerned, once you got that locked, they're in. So, but of course, it takes more than that. It takes the phase conjugate, it takes the reverse wave, and blah, 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 and on it goes, right? But once you meet all those criterias, things can get pretty interesting. So that's like my side thing. So I got the business, the company, and I'm part of for the energy stuff, and I'm trying to look at something that won't get me in trouble, and I can still experiment on my own with related stuff. And by in trouble, I don't mean like I'm not supposed in trouble, like non-disclosure agreements and in the energy domain, but nothing about communication systems. So it's another, why just use the vacuum for energy if you can use it for communications? What I'm getting at is if we're already tapping into it, may as well go all the way, right? I mean, anti-gravity is another one, but plenty of people are already dipping their hands and getting their feet dirty in that one. So why compete? Why compete? One of the reasons why I do the energy stuff is because even though there's like maybe thousands of people in the out energy field, I honestly feel that 99.9% of them are all out to lunch, and they actually do a disservice to the out energy community. And if you don't believe me, just stick around for 5 minutes in the over Unity research forums, and you'll know exactly what I'm talking about. But they mostly do a disservice to the community, and these are the ones that call themselves the experts. And if people keep following those people with the very high followings, they're actually not going to get anywhere. So I had made it, like a personal goal of mine as I learned this stuff to also distribute it and, filter out the BS. And here it is. This is what you got to do. Which is one of the reasons, by the way, even though I joined the company, I even made this in the contract that it's all my IP rights and they can't force me to delete all of my stuff. But they have a access to they have like I should say this, a right of way. They get the first rights on the licensing of any of my IP. That's how the agreement works. And I made sure because I didn't want to oh my goodness, disappear, delete my stuff. I've got a form and all the refinements over the years, just poof. So people were like, oh my God, when a year ago when I made the big announcement, people were like, oh, folks, back up everything now. His stuff is going to go. No. I worked too hard to just let it go. And I shouldn't say a bit, I have a lot of pride in it because, it filters out a lot of the BS. And that's why a lot of, 99.9% of the people in the over Unity research forums don't like me because, it gets right down to their BS, and then this is what you got to do, and the stuff actually works, and you've got other people writing about it in their own blogs and tweets and showing their own refinements, and then their engineers are going on there. Some of the comments, really made me laugh. I can't understand what determines the polarity in these cells. It's showing plus and minus, but how does it know? This is the engineer, right? Going like, it works, but how does it determine polarity? I'll never forget that when I read that, and in a way where it's trying to sound smart at the same time. I'm an engineer, and I built this, and it works. However, there needs to be a way to figure out what determines, we're trying to be a critic, a critique, right? This thing doesn't just decide on its own what polarity it is, meaning there's something, going on. But it was the way, I don't have the exact text, but it was the way he said it, It's like, it's mysterious that there is, how did he say that? How he couldn't tell how the polarity was being determined, especially when you use, two electrodes of the same, which others have demonstrated with the PEG cells, right? So it's like, how does the system determine? But if you really want to know, the Russell chart helps you determine that with the carbon being right in the middle. It's actually a bridge based on its elemental properties. So if you look at the Russell chart, essentially it's right there right in front of you, right? And that's what we're using. We're using carbon electrodes. So, food for thought. And it happens to be right there in the middle in the Russell chart. So a lot of coincidences. And like I said, I'm not making new stuff up based on Russell ideology. I just grouped it based on his ideas with the existing properties of the elements, and it gives it a neater and alternate perspective based on these groupings. But it just makes sense based on, the polarity, which is the gender, he calls it, of, matching the female part with the male part, and then you get the maximum effect. It just makes it easier than having to try and calculate it all the time. It's basically Russell's way of having, all of us basically have it, the resistor slider, where it's just a geonautical thing that moves around. If you're a little rusty in math, you match the colors and it tells you the impedance, right? It's just it's quick reference, makes what we already know easier to. So that's essentially how I see the Russell charts, right? It's just putting it easier. You dial in what you want and you get a easier to comprehend version of what that all means. So with that, I think I'm going to say good night for now. And again, thank you for spending time with me. And I'm going to try and actually make some content here, some offline content that's actually interesting. And with that said, just keeping everyone up to date here. Just trying to pass the winter. We're actually in March now, and it doesn't feel like it in Northern Ontario. It's still like minus 20 below, but maybe in the next 2 days. Could always wish, right? So with that said, have yourselves all a great day all, and thank you all for watching. Thank you.